This is an engineering drawing of our drilling rig. It contains the plan view, the side view, the back view. As you can see, we have our hoisting system consists of a 12-volt DC motor connected via a pulley to a threaded rod. As the threaded rod rotates, the top drive is controlled and moves upward and downward as the threaded rod rotates. Below we can see our hydraulic scissor lift. Our hydraulic scissor lift is put in place to hold the rock sample during drilling and to stabilize it, so it can be jacked up and down as required. So here we can see our caster tires which have been put in place to make our rig mobile. So our rig can be transported from one point to another and can also be easily moved. Yes, so what is highlighted is the hydraulic scissor lift, which will be used for rock stability during drilling. Drilled cuttings from the rock sample is transported to the mud tank via a hose which is put in place. So this is a highlighted view of the entire drilling rig system which we've designed and we are going to be building. The table behind is going to be where we place our computers doing work and the motors, and below there's a compartment where we can place the hydraulic triplex pump during the drilling process. This is the architecture of the system. So for our hoisting system, we're going to be using a high torque DC motor and an accelerometer. We're also going to be using a flow meter for our circulation system. For our safety, we're going to be putting an alarm system which goes off when the drilling rig is put on to inform people that the drilling is in progress. We're also putting an LED bulb which comes on when the drilling rig is in use. For our top drive, we're going to be using a high torque AC motor, an RPM sensor and a torque sensor. For our bottom hole assembly, we're going to be making use of a 3-axis gyrometer, a strain gauge load cell which helps us apply weight on the bit, a Bluetooth transmitter for our data, and then a battery. So our data gotten from the sensor goes to our logic controller. We're going to be making use of an Arduino. This data is then sent to our microprocessor. Our microprocessor, we're going to be making use of a Raspberry Pi. So our Raspberry Pi creates a wireless local host, and then this helps us. We're going to be creating a user interface that helps us visualize the data gotten from our sensors. This interface is going to have administrative access. So the team members and those working on the drilling rig can change parameters such as our rate of penetration, weight on bit, and other parameters required, and the data can be visualized and used to make better informed decisions during the drilling process. So they can be visualized both on your mobile device and your systems once you connect to this local server. So this is the algorithm we're going to be using for our drilling process, and this algorithm helps us know the effect our weight on bit has on our rate of penetration, and also helps us make changes during the drilling process, as we can measure the weight on bit in real time, and it directly affects our rate of penetration. Thank you for your